All right, so today's is something new and yet nothing super hard. Would you agree that this is fairly easy to solve, things like this, right? Okay, you just can get your two answers. I still have a frightening number of kids who will be able to do this one and say, oh, the answer is x is -2. That's right. And then they'll do this one and they'll think, oh, it's just the opposite of whatever this one is. So the answer to this is -1. No, can't do that. How do you do that second kind? You set the stuff inside what? Equal to 0. 2x plus 1 equals 0. So 2x equals -1, x equals -1/2. There's my two answers. Now what's new then? Well, you've already done that. What's new is fairly simple. We just have to change that to a greater than sign. And that changes the problem, not completely, but it changes the problem. Now it just wants, when is that greater than 0? Well, obviously these are still two important points, but notice that that looks like kind of the end of a number line there, see? And you therefore are doing a number line for this problem, and you put on -1/2, and you put on -2. Oops, I'm in the wrong order then. So here's where -2 would be. Here's where, no, I was right in the first place. Okay, so now I've got my two numbers on the number line, and now I got to test regions and see whether these numbers themselves work, and I should fill those dots in, and whether it works in here, or does it work in here, or here. And now this is an important point. What we did in the past was we would test numbers. Like, let's say we tested 0, which would be over here. And I put in a 0 here and a 0 here, and figure out what the answer is. Now, what's different now? All we care about on these kinds, since they're always set to 0, is are they bigger than 0 or are they less than 0? That's also known as, are the answers positive or negative? So I don't care exactly what answer I get. I just want to know, is that positive or negative when I put in a 0 here? It's positive. When I put in a 0 here, does this become positive or negative? Positive. I don't even care what number it is. I just care that it's a positive times a positive, which makes a positive. Are positives bigger than 0? Yes. So when I put in 0, it worked. The point is, in the past, we would have to find... Oh, you're right. I'm shading the wrong spot. In the past, we would have to find the spot exactly like what is the number you get. I don't care now. I just care whether this is positive or this is positive or negative. Let me give you another example. Let's say I had x minus 3 and x plus 7, and it's less than 0. All right. You get that the two important spots are 3 and -7. Now, here's the first part. Do 3 and -7 themselves actually work? Here's how you can tell. Those are what are called zeros. 3 is a 0. It means when I put it in, this whole thing will become 0. Is 0 less than 0? No, so it doesn't work. If there had been an or equal to sign, then would 0 be less than or equal to 0? Yes. So if it has an or equal to sign, then yes, it'll work, and you'd fill it in like this, solid. But if it's like this problem where there is no or equal to sign, it's just a less than sign, 0 isn't less than 0, so it's empty. And same with this. If you want to prove it to yourself, go ahead, put 3 in there and see what you get, and you'll end up getting a number that doesn't work. Because it'll be 0 times anything is 0. 0 is not less than 0. So it's empty circle here, empty circle here. And you test the other spots, but remember, you don't care exactly what the answer is. So if I test a number like in here, like 0, put in a 0, put in a 0, I get negative times a positive makes a negative. Do you get how I didn't even care that it was actually -21? It's a negative. Is negative less than 0? Yeah, so it worked. Works in here. And then try 4. In your head, think about it. Put in a 4 right here. So did you think to yourself, positive times positive? Good, that's what you should be thinking. You go 4 here and a 4 here. That makes a positive number and a positive number. Don't even care what the numbers are. Positive times positive makes positive. Is a positive less than 0? No. Didn't work. And would you assume this also doesn't work? I would assume that. But I'd want to check it just like on the test. -8. -8 here, -8 here. I get a negative times a negative makes a positive. And positive is not less than 0, so I was right. Doesn't work. Okay, now one more thing. If you could graph it, do you know what would happen? All right, I want to back up to the original, and I want you to actually type this into your calculator and graph it. Because some of them today, you'll have to graph them to solve them because they're too hard to factor. So type that puppy in, see what you get. I'll pause for a second while we do that. All right, so here is one I want to practice with you. This is on that worksheet I just handed out. It is number 7. Would you please multiply each term by something that gets rid of your fraction problem, cancel some stuff, reduce it. This is a typical, frankly, it's a pretty easy one, so it's probably like an R2 question. And a lot of you are going to get fooled. So, give it your best shot. Hit pause while you work at this. Number 7. All right, so we're back, and this is multiplied by x plus 2 everywhere. X plus 2, x plus 2, x plus 2. And it'll cancel here, it'll cancel here, and this one won't cancel, so I got to multiply it out. X times x makes x squared. 2 times the x, 2x. Minus the 3x right there equals 6. And then it's close. I just got to simplify some stuff. I end up with x squared minus an x minus a 6 equals 0. And then that factors x plus 2, x minus 3. There we go. That's it. No? Oh, I got to get the answers. Okay, the answers are x equals -2 and x equals 3. And then that's it, right? No, what's wrong with this answer? One of them doesn't work. If you look at the original, you can see that if a -2 got put in there, it would crash it. So cross that off. The only answer that's correct is x equals 3, and that was D as in dog. Raise your hand if you had that one right. Awesome, nice job. I know a lot of you probably got fooled by that and put A, and it's a really easy mistake to make. All right. How about number 10? Try it. It's a mixture problem. If you remember the mixture formula, it'll be a snap. Those following along at home, it says 10 liters of a 20% solution. Are mixed with 30 liters of 30 solution. Which of the following is percent of acid in the final mixture? Obviously, they wouldn't ask you how many liters do you have, because they tell you you had 10, you had 30, it's going to be 40 liters. Well, your formula you need to know, amount 1, percent 1, plus amount 2, percent 2, equals amount 1 plus amount 2 times the total percent. Awesome formula. Helps in a lot of ways. You can use this for finances too. We'll do one of those in a moment. So this one's amount 1 is 10, percent 1, 0.20, plus amount 2, 30, percent 0.30, equals amount 1 plus amount 2, that's 10 plus the 30 makes 40. And this I don't know, so I put an X. And this one's 2 plus 30 times 0.3, 3 times 3 makes 9. Move the decimal, it's just plain 9. And I get 40x. And this is 11 equals 40x. So x is 11/40ths. If you got a decimal for that, that's fine. But 11/40ths is my x, which is my total percent. I guess I really should figure out the decimal. Does anybody divide that yet? 27.5%? All right. Raise your hand if you had that one right. Okay, good. Now, last one. I want you to use the fact that you know this formula and trust that this formula will work for this. Let's say that you have a wealthy client comes to you and you are a financial planner and he says, I have got $600,000 in the stock market, and the stock market has averaged 9% per year for like the last 50 years on average. Okay, so he's got 600,000 at 9% return on your money. He's got another $250,000, and he's going to put it in some other investment, but he doesn't know how much it's going to get him. Doesn't know what percent he's going to get on it. But he wants to average an overall 10% return on his money. He wants his total percent, his average overall, to be 10% return on his money. He's getting 9% on most of his money. This one he wants to be a little more risky with. And so he wants to know, what percent do I have to get to make my total mix be 10%? You see how the percent asset and the percent return on your investment is like the same thing? So this formula is really pretty cool for investing too. So you'd go 600. I'm going to shorten it to 600 instead of 600,000 times 0.09 plus 250 times I don't know what equals 600 plus the 250 makes 850 times the total mix he wanted was 10% return. Let's invest. So this will be 554. Yeah, 54 plus 250x equals 85. And then 250x. It's 31 over 250. 12.4%. Can anybody verify that? That same thing. Okay, that was a lot of smart hands. All right, good. Do you get how that could be handy in a lot of ways? It's not just mixtures of alcohol or mixtures of acids, or it could be mixtures of amounts of money earning different percents. I got a little sloppy at the end there. Some kids are looking up here with puzzled looks. I want to make sure you're getting this right. This was 31 divided by 250. 31 divided by 250. Are you sure that's 12.4%? Okay. All right, good. All right. So any questions about, like, how did you get from here to here, or anything you want to ask? I'm willing to clarify. All right, you can always ask me later, and I'll come back to this slide. All right, I'm going to go on and make sure you get how to do the new stuff. The new stuff we talked about already, just big picture. You're going to have some that you just are already factored, and they'll be easy. And you'll say, oh, number line, because see, it's got a tip of a number line on there. So it's a number line problem, and I just got to put 3, and then be careful on that one. It would not be -1. What would it be? -0.5. And then I test all these spots if you're not really awesome at this. But for me, I know that since this is just a greater than sign, that these spots won't work. I don't even need to test them. Leave them empty. If it had been or equal to, then I would have filled them in. Okay. So, since it's not or equal to, it's like this. Now I'm going to test the spot at 0. I put in a 0 here, put in a 0 there, and I just think that's positive, that's negative. A positive times a negative makes a negative. Is a negative bigger than 0? No. So that didn't work. And I probably am going to have it work here and there. But I really should test. I'm going to test 4 and see if I put a 4 here, that'd be 8. That'd be a positive. 4 here, that'd be a positive. Positive times a positive, is that bigger than 0? Yes, it is. So it worked. All right. And then the harder kind you'll have like this. That's just an awful, nasty one. What do you do with it? You graph it. Once you're done graphing it, let's say it does something like this. And if I want to have it be greater than or equal to 0, then where is it greater than 0? Wherever it's above the line. All the places that I put in blue here, that's where it's greater than 0. So let's say this spot here was at 1 and this was at 7. Then I would say it's greater than or equal to 0 between negative infinity and 1. And it's okay at 1 because it says or equal to. It works. Okay, so 1 works. Union with 7 to infinity. 7 is a 0. 0 is greater than or equal to 0, so it works. Bracket. There'd be my answer for that. All right, so let's do one like that together. There's a worksheet for that. The worksheet you have in your hands right now, remember, is extra practice problems you can do if you wish. This one I'm about to hand out is your homework. It is assigned. I'm going to have you skip a few of them, but this is the assignment for tonight. All right, let's do number 8 together. Oh wait, let's do number 1 first. It's pretty easy, but it fools people sometimes due to just a little tiny thing that people don't notice. Let's do number 1. It says x plus 1, and then it says x minus 3 quantity squared, and then it says greater than 0. This is not a graphing one, because it says do it algebraically. Okay, it says support graphically. That means you could check it with your calculator, but don't even bother. These are pretty easy. It wouldn't hurt you to graph it, but you don't have to in my class. Some of your teachers might be requiring you to graph it, but I'm not. All right, so on number 1, do I have to have the XY kind of way to do it? Not really, but you could if I wanted to. Negative 1 and positive 3 are my 2 spots. All right. Does it work at those spots? No. Empty circles. And then if I'm going to test a spot, I'm going to test something like 0. Okay, so here's where 0 is. If I test a 0 in here, all I need to know is it positive or negative? And a lot of people just go quick and they go, positive times a negative makes a negative. Wrong. What's wrong with that? It's squared. That's what a lot of people don't notice. See, that negative is getting squared, which makes it positive times a positive. Positive times positive makes a positive. Is positive greater than 0? So it works in here. And what does that mean? That means that the graph would be above 0 in here. Does that make sense to you? Do you remember from what we learned about these that there's a bounce going on at 3? So this is actually what's happening, like this, see? And do you remember if this is a total degree of 3 that they have to be going opposite directions? So I know my graph kind of looks like this. If I wanted to think about it as a graph, see? Now I know it was going to work here, and can you also tell it's going to have to work on the other side of the 3? See what I mean from my little sketch? Otherwise, if you want to, go ahead, take a 4, plug it in, see what happens. So say I put a 4 in right here. I'm going to get a positive and a positive, and the positive is being squared even, so it's really, really positive. Is positive greater than 0? Yes. So see, it does work out here. Does it really not work at like negative 2? Well, to check it, put a negative 2 there, put a negative 2 in right there, and I have negative 2 plus a negative times anything squared is going to be positive, isn't it? See how I don't even have to check this one anymore? Because it's squared, so no matter what I put in there, a negative or a positive, that part's positive. Okay, so this part's positive times this part would be negative if I put in a negative 2. So it becomes negative. And is negative greater than 0? No. So it really doesn't work there. Final answer, negative 1 to 3 doesn't work at either spot. Union with 3 to infinity. All right. And then the harder kind of the kind like number 8. Number 8 is, I've got it graphed on my calculator. I'm going to share this one with you so that you don't have to wait a long time of typing to see that graph. Okay, there's the graph for number 8. Number 8's problem asks where the function is less than 0. Can you see that this is the only place where it's less than 0? All right, so I need to know what that point and that point are. How am I going to figure that out? I can just kind of look at it and see where the tick marks are. There's a tick mark here, there's a tick mark here, and a tick mark there. That's 1, 2, and 3 on the graph. So you can see that one of them is 2. What would you guess this spot right there is then? 1.5. Yep, and you're right. Now, how would you know for sure? Trace works. Trace is not a bad thing. I mean, a lot of times people think, well, we have to use that second calculate thing. Not really. You can use trace. Now, I need to find where the little spider is, so I'm going to move the surround until I finally see him. There he is. And I'll get the little spider right there. Oh, just went past it. So you can see I'm just a smidgen more than 2, 2.02. And then I get down here and I'm at 1.96. You can pretty much tell it's 2. Now I'm going to go back here and see if this is really about 1.5. I'm at like 1.53. Now I'm at 1.47. Yeah, that's got to be 1. So trace is okay. Technically, if you wanted to do this exactly right, you'd use the zeros. Second, calculate. The 0 is the 2 there. And then it wants to know left boundary. I am to the left of that spot. Go to the right of it. Enter. Guess exactly where it is. Close enough. And it says, yep, I'm at 1.5. This confuses a lot of people. Remember, it means 0. It means 1.5. Move the decimal 12 spots to the left. So that's... I went off. Anyway, it's got a lot of zeros and then a 12. That's pretty much 0. Okay, so don't let that confuse you as it being a number. It's supposed to be about 0. Okay, so that's enough help for now. I know that some of you might want some help individually. I'm willing to help you. Just ask. And that worksheet 2.8, number 1, it is assigned, and I did tell you I'd have you skip a few. You may skip 15, 16, and 17 to keep your life a little more reasonable. Skip 15, 16, and 17. Remember to cross them off light enough so if you wanted to do more practice later, you could. All right. Okay. Got some time for work.